Hello students, in today's class we'll be studying the examples of aromatic and non-aromatic compounds. We'll also be looking at anti-aromatic compounds as well. We know that when it comes to aromatic compounds, we just have few rules. It should be cyclic in nature. It should be conjugated in nature. It should be planar in nature. And it should follow Huckel's rule. Now, what is cyclic? It should be a closed structure. What is conjugated? It should have sigma, pi, sigma may be a lone pair, sigma may be a positive bond, something like that. That means no two sigmas together, no two pi bonds together. That is conjugated. Planar, we know that it will always be planar. All the structures given to us will be planar in nature. And finally, we have Huckel's rule. Huckel's rule is nothing but 4n plus 2 pi electrons, where n is nothing but the number of rings. And thus, n can be 1, 2, 3, and so on. So if I have 4 into 1 plus 2, it becomes 4 plus 2, which is equal to 6. If I have 4 into 2 plus 2, it becomes 8 plus 2, which is 10. If I have 4 into 3 plus 2, it becomes 12 plus 2, which is 14. And eventually, these are the numbers which we have to remember. Now, let us start with the first one. This is the first example we have over here. Is it cyclic in nature? Yes. Is it conjugated? Let's see. We have pi, sigma, pi, sigma, pi, sigma, pi, sigma. Yes, it is conjugated in nature. Is it planar in nature? Always it will be planar in nature. Now let us see number of pi electrons. It has 1, 2, 3, 4, 5, 6, 7, 8. Is 8 coming in any of this? No. But it comes in the anti-aromatic formula, which is nothing but 4n. If I have an anti-aromatic compound, the formula is just 4n. So we have 4 into 1 as 4, 4 into 2 as 8. And we have 8 electrons over here. That means my first compound is nothing but anti-aromatic compound. Let's try with the second one. This is my second option over here. Is it cyclic in nature? Yes, it is cyclic in nature. Is it conjugated? Let us check. Sigma, pi, sigma, and a lone pair. Yes, it is conjugated in nature. Is it planar in nature? Always. Now, how many pi electrons does it have? It has 1, 2. And if we consider this, the negative sign as a lone pair, then I have 3 and 4. So again, is it aromatic in nature? No, it is not aromatic in nature. Let us see the third and the fourth one over here. So over here, for the third one, this is the triangular one, which is the third one. Is it cyclic in nature? Yes, it is cyclic in nature. Is it conjugated in nature? Let us see. Sigma, pi, sigma, and over here I have a positive bond. So yes, it is conjugated in nature. Is it planar in nature? It will always be planar in nature. Then What will we check for? Huckel's rule. Does it contain the number of electrons? It's just 1 and 2. So it is not aromatic in nature. Let us see the fourth one over here. Again, we have the same conditions, cyclic. Is it cyclic in nature? Yes, this particular fourth example is cyclic in nature. Is it conjugated in nature? Let us check if it is conjugated or not. It is pi, sigma, 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 pi, sigma. That means I have 1, 2, 3 sigmas together, and thus it is not conjugated. It is non-aromatic in nature. What are non-aromatic compounds? Which do not fulfill the first 3 criteria. That means, of course, it will always be planar in nature, no matter what. But over here, we do not have to consider for Huckel's rule at all. Why? Because at this point of time, we realize that the second one is not fulfilled. That is the reason why it goes into the non-aromatic list. Over here, we have a few more. Again, if you see this one, all the 3 of them are cyclic. All the 3 are cyclic. First, second, third. Let's talk about conjugated. Let's go with the first one over here. We have sigma, pi, sigma, pi, sigma, and positive. First one is conjugated. Let us see over here. Sigma, pi, sigma, pi, sigma, and negative. That means lone pair. You should remember no 2 sigmas together, no 2 pi's together. It is okay if you have a positive sign or a negative sign. It is just that they should not be together. They should be separated by something. So over here they are separated by a negative sign. Over here they are separated by a positive sign. So both of them are conjugated. Let us check over here. Sigma, pi, sigma, pi, sigma, pi, sigma, positive. Again, conjugated. Now, planar. As I said, all 3 of them will definitely be planar in nature. So, there's nothing to worry about that. And finally, we have to follow Huckel's rule. And what is Huckel's rule? 4n plus 2 pi electrons. Let us count over here. 1, 2, 3, 4. No, this is not aromatic. Let us count over here. 1, 2, 3, 4. And a lone pair is over here. 5, 6. Negative is nothing but a lone pair. So yes, this particular, the second one follows Huckel's rule. Let's check for a third one. 1, 2, 3, 4, 5, 6. And this is positive. So how many are there in total? 6. So even third one follows the Huckel's rule. So second and third both are aromatic compounds or aromatic in nature. Easy? Understood? Let's see the next ones. Again over here, for both of them, we'll first check they are cyclic or not. Of course, both of them are cyclic in nature. Are they conjugated? If you see the first one, you have sigma, 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 sigma. So many sigmas together. So the first one is not conjugated. Since it is not conjugated, it becomes a non-aromatic compound on its own. Let's see for this one. Let's start from here. Pi, sigma, pi, sigma, pi, sigma, pi, sigma, pi, sigma. So all of these are nothing but sigmas. You have a pi over here, sigma, pi. Then you have a sigma, pi, sigma, pi. So all of these are nothing but sigmas and pi's together. And because of these sigmas and pi's together, this becomes a conjugated compound as well. Now, if you see over here, this is nothing but a benzene ring. This particular bond is shared over here as well as over here. This particular bond can be shared over here and as well as over here. So this becomes like one benzene, this becomes like second benzene, this becomes like third benzene. That is the reason why first they are planar and they will follow Huckel's rule, making this nothing but an aromatic compound. It's just a big compound. It is small aromatic compounds clubbed up together, making it a big aromatic compound. Now we have over here benzene and toluene. Benzene again, is it cyclic in nature? Yes. Is it conjugated in nature? Let us see whether it is conjugated or not. Pi, sigma, pi. Sigma, pi, sigma. Yes, conjugated. Is it planar in nature? It would always be planar in nature. And does it follow Huckel's rule? The last thing we need to check is for the Huckel's rule. Let us count the number of pi electrons which are there over here. 1, 2, 3, 4, 5, and 6. 6 pi electrons. So thus benzene is an aromatic compound. In the same way over here also, is toluene cyclic in nature? Yes, it is cyclic in nature. Is it conjugated? Let's see. Pi, sigma, pi, sigma, pi, sigma. This is just an extension. CH3 is just an extension. So yes, it is conjugated in nature as well. Is it planar in nature? It will always be planar in nature. So the only thing we need to find out now is the Huckel's rule. And we need to calculate the pi electrons present in the Huckel's rule. So 1, 2, 3, 4, 5, 6. So we have 6 pi electrons, making it again an aromatic compound. This is how we classify which compounds are aromatic in nature, which compounds are non-aromatic in nature, and which compounds are anti-aromatic in nature. Over here also, we have xylene and biphenyl. Let us start off with xylene. Over here, we again have a cyclic compound. We have attachments which are attached over here, and the second attachment OMP xylene. So some attachments are over here. It can be, it's seen over here, but it can be over here and here as well. But the attachments are not important. So what is important is the compound. Is it cyclic in nature? Yes. Is it conjugated in nature? Let us find out that. Sigma, pi, sigma, pi, sigma, pi. Yes, conjugated in nature. It will always be planar in nature. And what about the Huckel's rule? 1, 2, 3, 4, 5, 6. 6 pi electrons following Huckel's rule. It is an aromatic compound. In the same way, we'll also find out for biphenyl. I'll just erase this C out properly and write it back again. It's an aromatic compound. For biphenyl, is it cyclic in nature? Yes. Is it conjugated in nature? Let us see. Sigma, pi, sigma, pi, sigma, pi. Then you have sigma over here, pi, sigma, pi, sigma, pi, sigma. Conjugated in nature. Is it planar? It will always be planar in nature. What about the Huckel's rule over here. Now, what does Huckel's rule say? That it should have 6 pi electrons or 12 pi electrons and so on, right? So now let us first calculate whether how many pi electrons are there in a single cyclic ring, because that will be twice for the next one. So it is 1, 2, 3, 4, 5, 6. 6 pi electrons for this ring. So it will be 6 over here as well. Let's calculate once. 1, 2, 3, 4, 5, 6. So 6 pi electrons here as well. So it becomes 6 plus 6, which is equals to 12 pi electrons. And thus even this becomes an aromatic compound, a compound which is aromatic in nature. The easiest way to classify is this. Let us again see over here in the first one you have is first let's see whether it is cyclic or not. Yes, the first one is cyclic in nature. The second one is also cyclic in nature. So for both of them cyclic is correct. Now what about conjugated? Let's start from here. Pi, sigma, pi, sigma, pi. But over here if you see the sigma and sigma together, since there are two sigmas together, when it comes to conjugation, the first one is not conjugated and it directly becomes a non-aromatic compound. For the second one, let's see the conjugation for the second one. Pi, sigma, pi, sigma, pi, sigma. Then over here from pi you have sigma, pi, sigma, pi, sigma. It is conjugated. It will obviously be planar in nature. Now let us calculate the number of pi electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does it come into 4n plus 2? What is it? 4 into 2 plus 2. 4 into 2 is nothing but 8 plus 2, which is equals to 10. Over here we counted a total of 10 pi electrons. Over here we have 10 pi electrons, and thus this becomes an aromatic compound. So in this way we can classify whether the compounds are aromatic, non-aromatic or anti-aromatic. We have a triple series over here. Now this triple series, for both the compounds it is the same. You have 3 benzene rings for both of them. So let's first classify both of them. Cyclic, yes. Cyclic, yes. Conjugated, sigma, pi, sigma, pi, sigma, pi, sigma, pi, sigma, pi, and so on. It is just going on and on. So this pi electron can be shared over here as well. Pi and then sigma. Then over here you have a pi, which I have already written over here. Sigma, pi, sigma, pi, sigma. Yes, it is conjugated as well. Let us calculate the number of electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 4 into 3 plus 2. 4 3s are 12 plus 2, 14. Same number of electrons which we found from here. Yes, this is aromatic in nature. This is an aromatic compound. And this particular compound is same as this compound. The only difference is over here we had the benzene ring over here. Instead of having the benzene ring over here, we have the benzene ring on the top. So even this will be an aromatic compound. This compound will also be aromatic in nature. And this is how both the compounds are similar. Thank you so much for watching this video. In this video, we studied about classifications of aromatic, non-aromatic, and anti-aromatic compounds. We also study how to go about and characterize the same. Thank you.